Okay, so let's continue solving this projectile motion problem. We found the initial velocity in the x direction and we found the initial velocity in the y direction. So you can write that down on your givens. Okay, and here I pretty much gave you the formula for how to solve the initial velocity in the x direction, which we already did, and the initial velocity in the y direction. Okay, so now one thing that I want to explain to you before we continue is that I want to show you that the velocity in the x direction never changes. Okay, that's why I drew this purple arrow up here. So that's one thing you should remember, because this could be a question on your exam. The velocity in the x direction is never ever going to change. Okay, it stays the same whether the ball is over here or whether the ball is over here or over here or over here or all the way over here. It will never change. What changes is simply the velocity in the y direction. Okay, so when the ball is going up, the velocity in the y direction is actually getting smaller and smaller and smaller until there is no velocity in the y direction. Okay, so this is the point where the velocity in the y reaches 0. And then when the ball continues to fall down, the velocity in the y direction is going to start increasing all the way until the ball hits the ground. Okay, and one more thing that you should know is that because this is a parabola and parabolas are symmetrical, whatever measurements you get for this half of the parabola are going to be exactly the same for this half of the parabola. So for instance, if we find the time it takes the ball when it's being kicked all the way till it goes up here, if we find how much time it takes from the beginning to this point, to this middle point, we can actually use symmetry to find the total time. Okay, because this the projectile motions are, a lot of them are symmetrical problems, like this one. This is symmetrical. So use that to your advantage. Now let's go ahead and let's start solving the problem. So the first question, it says, at what time will the football reach the highest point? Okay, so this here is the highest point. We want to find out when is the ball going to reach the highest point. Now to find that, I'm going to go ahead and just give you the kinematic equation that you need to use. Okay, well, it looks like we're getting to the end of that. Okay, so let's use this kinematic equation. V velocity in the y direction, so this is the final velocity in the y direction, is equal to the initial velocity in the y direction plus the acceleration in the y direction times the time. Okay, and let's use this equation, and you'll see why I chose this one in just a second. Okay, so I chose this equation because we have another given. Okay, and I didn't write this one down, but I'm going to tell you what it is right now. Since we're trying to find the ball reaching this middle point, you need to know that the velocity in the y direction at this point is 0. Okay, there is no y vector in this at this point. Okay, because at this point the ball is not traveling up and down. At this point the ball is still. So there is no y direction. So we just found the final velocity in the y direction, which is 0. Okay, and that is that should be a given. Actually, you should write that down in the givens. Okay, so this one is the initial velocity in the y direction, which we solved. We said that the initial velocity in the y direction is 29.6, and it's positive because the ball is traveling upwards. We found this over here. Let me show you. Okay, 29.6. We had found this already. Okay. Now we need to write the acceleration in the y direction, and the acceleration in the y direction is simply gravity, and gravity pulls the ball down. Okay, and we said that the down direction is negative, so I'm actually going to put a negative here, negative 9.8, Meters per second squared is the acceleration due to gravity, and this is being multiplied by the time. We don't know what the time is, so we need to solve for it. Okay, so to solve this, it's just a simple algebra problem. I'm going to move the 29.6 to the other side. So it's going to be negative 29.6 is equal to negative 9.8 times the time. Now to solve for t, divide by negative 9.8 on both sides. And t is equal to, use the calculator for this. Okay, so we have negative 29.6 divided by negative 9.8, and you get 3.02 seconds. Okay, so it takes 3.02 seconds. This is the amount of time it takes the ball to make it halfway. Okay, so it takes 3.2 seconds for the ball to reach half the distance. So that is the answer to problem A. Now for problem B, it says how long does it take the football to hit the ground? So in other words, how long does it take to go all the way? Now I already told you about symmetry. Okay, this problem is symmetrical, so if you know that it takes 3.02 seconds to go half the distance, then to go all the way, you know it's going to take 6.04 seconds. Okay, so if this is half the distance, then to go all the way, it's going to take 3.04 seconds. This is the time to go all the way. So this is the answer for part A, and this is the answer for part B. Okay, symmetry is very important in this problem. Let's go on to the next question here. It says, how far did the football travel horizontally? So now we need to use a kinematic equation in the x direction to find out how far the football travels in the x direction. So what they're asking for is this distance down here. Okay, so now the kinematic equation that I'm going to use is x is equal to x initial plus the initial velocity in the x direction times time plus 1/2 acceleration in the x times the time squared. Okay, so this is the equation I'm going to use. Now x is the final distance which we are trying to find. The initial distance is 0 meters. Okay, the initial velocity in the x direction is, we said it was 22.2 meters per second. This is something we found out already. And the time that it takes to reach the total distance is actually 6.04 seconds. You need to use 6.04 seconds because that's the time it takes the football to reach all the way to the end. Okay, now this part up here you don't need to use. This part cancels out because there is no acceleration in the x direction. Remember, there's only acceleration in the y for this type of problem. So this is 0. Now this just turns into a simple problem where you just plug it in the calculator and you get an answer. So 22.2 multiplied by 6.04 seconds, and you get the distance equal to 134. Okay, so that is the distance, 134 meters is the total distance. So this is part C. Okay, let's go here. So we just found out that from this point, okay, from the beginning all the way to the end, the football travels at 134 meters. And finally, problem D says, what is the speed of the football when it hits the ground? Well, this has nothing to do with components. Okay, problem D has nothing to do with components. It has to do with the actual speed of the football. We know that the football was kicked at an initial speed of 37 meters per second. Okay, and based on symmetry, the football is going to go up, right? And it's slowing down as it goes up, and it's going to reach 0 meters per second when it goes up here at this point. But then the football is going to accelerate as it goes downwards. Okay, and because there is symmetry, if you started off with 37 meters per second, then the final velocity is also going to be 37 meters per second. Okay, so choice D is also 37 meters per second because of symmetry. Now this is very important because this is the reason why you should never shoot a gun up. If the bullet is being shot upwards, then when the bullet comes back down, it's going to come back down with the same speed in which you shot it upwards. And that's the same thing that's going on in this problem. The football is being kicked at 37 meters per second, and when it goes down, it's also going to come down and it's going to hit the ground at 37 meters per second. And that is how you solve this projectile motion problem.